Good evening, dear students. Today we are going to see a new lesson, biomolecules. It's called biomolecules. Biomolecules, what are called biomolecules? All human beings or living beings contains carbohydrates, proteins, lipids, and then nucleic acid. So all living beings mostly contain the biomolecules like carbohydrate, proteins, and lipids and nucleic acids. Okay, all the living beings. In that the human being contains mostly the elements, important elements of human being: carbon, hydrogen, nitrogen, oxygen, phosphorus. These are the very important elements present in our human body. Okay, more than that also is there, but these are the very important elements. These various combinations come under the biomolecules. They are very important for the activities of human being and animal and all living organism. They do many works. The combination of these elements. Okay, they are called biomolecules. Biomolecules we can define like this: all biological process. What is the chemical view of biological process? Or what are the chemical reaction behind the biological process? Or what are the essential molecules or the essential chemical molecules for the biological process? They are called biomolecules. There is a separate branch of chemistry that is called biochemistry. In a chemistry lesson, we are having the lesson is called biomolecules. Okay. Among the biomolecules, today we are going to see about the carbohydrates. Okay. Carbohydrates. Carbohydrates. Okay, you know very well that carbon plus hydrogen may give a hydrocarbon. This is called a hydrocarbon. When a carbon plus hydrogen plus oxygen is a carbohydrate. So the elements which are present in a carbohydrate: carbon, hydrogen, and oxygen. These are mixed together to give a various composition. They will give a carbohydrates. Okay. Carbohydrates are also otherwise called as saccharides. Okay, saccharides, which mean sugar. Okay, most of the carbohydrates are sugar in taste, so they are given as a saccharides. They named as a saccharides or carbohydrates. The chemically it can be called as a polyhydroxy. Carbohydrates are called as a polyhydroxy aldehyde or ketones. Polyhydroxy aldehyde or ketones. Carbohydrates, chemical term. In a chemical term, we can call the carbohydrates polyhydroxy aldehydes or ketone. So generally they are called saccharides because they are sweet in taste. Okay. Then the saccharides, sugar. There is a name is derived from sugar. Saccharides, mostly carbohydrates, a content of carbon, hydrogen, and oxygen. These are the three elements present in a carbohydrate. Chemically, the chemical term, carbohydrates are named as a polyhydroxy aldehyde or a ketone. Polyhydroxy aldehyde or a ketone, they are called as a carbohydrate. The general formula for the carbohydrate is CnH2O n times. This is a general molecular formula for carbohydrate, CnH2O n times. Here the hydrogen and oxygens are same ratio as in a water. How water contains hydrogen oxygen ratio, the same ratio in a carbohydrate. So the general molecular formula for the carbohydrate is a CnH2 n times. This is a general molecular formula for the carbohydrate. Then preparation, how we can prepare, that is you know very well the photosynthesis. In photosynthesis, what is going to happen? 6 times of carbon dioxide plus 6 times of water molecule. Okay, this is in the presence of sunlight under the green leaf, green pigment, that is called chlorophyll. So you are getting that carbohydrate, that is glucose C6H12O6 plus 6 times of O2. Okay, this is a reaction you have seen familiarly in your lower standard itself. This is called photosynthesis. This is one of the carbohydrate. Okay, now carbohydrate, how it is prepared from the photosynthesis. From photosynthesis, the carbon dioxide plus water, 6 times of carbon dioxide, 6 times of water in the presence of sunlight and chlorophyll, you are getting that glucose. Okay, this is called the preparation of carbohydrate. This is the main way to prepare. Now let us see the configuration of carbohydrates. Configuration of carbohydrates. Configuration of carbohydrates. So the simplest carbohydrate, glyceraldehyde, they are contained in the formula like this. So configuration, it means D form and the L form. Okay, D and L form. There is a big difference between the plus and minus and D and L. That you should know very well in isomerism. In isomerism, the plus and minus are representing the optical rotation. Whether the plane polarized slide, the molecule rotate the plane polarized slide towards the clockwise direction, that is plus. Okay. And then minus, that is anti-clockwise rotation. Okay. But this is something different. D and L form representation is something different from the optical isomerism, so you should learn from this. I have taken the glyceraldehyde. This is called a D-glyceraldehyde. D-glyceraldehyde. Okay. Then, if you see, this is L-glyceraldehyde. What is the difference between these? See, this area. This is L-glyceraldehyde. Okay, this is L-glyceraldehyde. D form and L representation. So based on this, if you find this representation on any of the carbohydrate, that is called as the D form, D representation. If you find that L, this type of representation, that is called a L form. For example, we can see then erythrose. This is 3 carbon, then 4 carbon content. Example, we can see. This is called a D-erythrose. D-erythrose. Now what for L? See, the D-erythrose, you can find this structure. This is important. The same as in a D-glyceraldehyde. H this left side and O is right side. So what about the L-glyceraldehyde? L-erythrose, CHO, CH2OH. L means OH this side, OHH. By looking this, you can see the L form. See, L-glyceraldehyde, the same way L-erythrose. If contain 4 carbons, 5 carbons, you can see right like this. Each carbon is a carbon. In the representation of Fischer projection, you know that very well. This is a carbon, one carbon. So 1, 2, 3, 4, 5. Here 1, 2, 3. If you take 1, 2, 3, third carbon. Here 1, 2, 3, 4, fifth carbon. 1, 2, 3. So this is a line. 3, 4, 4 carbon. Here if you see 1, 2, 3, 4, 5. 5 carbons. This is called ribose or ribose. D, ribose, ribose, or sometimes it is called ribose. Then how it will be? See, look at the why it is called D, sir. See, this is a configuration you are finding here. The same configuration. This is D-glycerolide. Likewise, if you want to draw the L, OH, 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 H, H, H. Okay, and you see, look at this. This is L, ribose or ribose. Then, if carbon contains 6 carbon, what to do? That is familiar example. Glucose we can have CH2, CH2, O plus. You want D-glucose, draw like this. So glucose contains 6 carbon. Look at the 6 carbon. Another 1, 2, 3, 4, 5, 6. 6 carbon is there. There is a what is called a. If you want doubt, you get a 5th carbon. So C5. It is similar like a glycerolide. This is called a D-glucose. D-glucose. Then L-glucose. Same way. Last carbon. This is last carbon, CH2, 6th carbon. Now here, this should be the 2 and the 5th place is varying. OH, H, and it should be H. Again, here OH, H. What is there? HOH. So you may find this. Okay, this is L glucose. These are the configuration of carbohydrates, especially monosaccharides. If you see that D form and L form. D form and L form is mostly based on the glycerolide. See, glycerolide, the second carbon, before the last carbon, left side H will be there. For OH will be the right side for L. So the D-glycerolide, L-glycerolide. Okay. Then if you continue that for 4 carbon erythrose like this, if you same structure you find here, that is a D form. Like L, glycerolide, if you see, there is L form. The same way ribose and glucose also. Okay, this is a configuration of the carbohydrates. Then let us move on to the classification of carbohydrates. Let us see the classification of carbohydrates. Classification of carbohydrate. Okay. Based on the taste, carbohydrates may be classified into carbohydrate may be classified into 2 types. One is a sugar and non-sugar. For example, glucose is a sugar, starch is a non-sugar. Okay, sugar in taste, that is get pre-classified as the sugar and a non-sugar. Then, based on the hydrolysis, based on the hydrolysis, carbohydrate may be classified into carbohydrates can be classified into these types. Monosaccharide, monosaccharides, oligosaccharide or oligosaccharides, then polysaccharides. This is based on the hydrolysis how the carbohydrate can be classified into monosaccharide, oligosaccharide, polysaccharide. What is called as monosaccharide? When a carbohydrate is hydrolyzed, when you hydrolyze the carbohydrate, you are getting monosaccharide units. The monosaccharide is nothing but it cannot further hydrolyzed. That's all. It's simplest carbohydrate that cannot be further hydrolyzed. That is called monosaccharides. So no more hydrolysis takes place in that. That is called monosaccharide. One unit, monosaccharide unit. Where what about the oligosaccharide or oligosaccharide? The oligosaccharide is nothing but when you hydrolyze it will give 2 to 10 units of monosaccharide. 2 to 10 units of monosaccharide. The oligosaccharide will give 2 to 10 units of monosaccharide units. Okay. If simply there is no more hydrolysis, that's all at last end, that is called monosaccharides. When carbohydrate for hydrolysis to give 2 to, it may give 2 monosaccharides or till 10, 2 to 10 units of monosaccharides, then they are called as a oligosaccharide. It is polysaccharide, more than 10, they are called a polysaccharide. More than 10, when you hydrolysis, number of monosaccharide units is present in that, they are called as, or more than 10 monosaccharide units are as a product when you hydrolysis, then they are called as a polysaccharide. Then based on the reducing nature, based on the reducing property, carbohydrates can be classified into 2 types. That is called a reducing sugar. Another one is a non-reducing sugar. So reducing sugar, non-reducing. These are the way how to say, because when a carbonyl compound is free in the structure of the carbohydrate, that is called reducing sugar. For example, glucose, fructose, they will come under the reducing sugar. Whereas a non-reducing sugar, when it is linked to the glycosidic linkage, further you may study in forthcoming classes, you may study the structures of each and everything. There you may find that linking, how monosaccharides are linked. The linkage is called a glycosidic linkage. While it linked with another monosaccharide, the carbonyl compounds of the particular keto group or aldehyde group is not free. If they are not free, mean they cannot reduce. So that is called non-reducing sugar. If for example glucose, if you take in the structure of glucose, you will study later, the structure of glucose, if you see there is a aldehyde group is very free, then it is called reducing sugar. If you see the structure of fructose, when glucose and fructose are mixed together to give sucrose, that time in that structure, if you see the aldehyde group of glucose and the keto group of fructose are mixed together, linked together, they are not free. If carbonyl compound is not free, it cannot reduce, that is non-reducing sugar. Okay, these are the classification. Now this classification can be made to the flow chart. If you see that flow chart, you may get more clear idea about this. The same classification: carbohydrate. Okay, carbohydrate can be classified into 2 types. One is a sugar. Another one is a non-sugar or a polysaccharides. Non-sugar is also called as a polysaccharide. Non-sugar and then is a polysaccharide. Sugar, further it is categorized into 2 types. One is a monosaccharide. Another one is a oligosaccharide or oligosaccharide. Okay. Monosaccharide, further it is classified into aldose, ketose. Based on the functional group. Functional group present is aldehyde, then it's called aldose. The functional group present is that monosaccharide, that is called ketose. The oligosaccharide can be further classified into, because oligosaccharide contains 2 to 10 monosaccharide units. How many monosaccharide units are there in oligosaccharides? 2 to 10. So it may be further classified into disaccharide, trisaccharide, and further it is tetrasaccharide, penta, and so on. It may further exceed till 10. Okay. So sugar, it can be carbohydrate. You can classify it into 2 types. One is a sugar, another one is a non-sugar. Sugar, the non-sugar is called polysaccharide. Then further sugar can be classified into monosaccharide and oligosaccharide. Monosaccharide further classified into, if contains monosaccharide contains aldose, aldehyde, then it's called aldose. If monosaccharide contains ketone, then it's called ketose. Okay. Likewise, oligosaccharides, if you are having the what do you mean by oligosaccharide? Oligosaccharide, the carbohydrate which contain 2 to 10 monosaccharide units in it, they are called as a oligosaccharide or oligosaccharides. In oligosaccharides, there are different types till disaccharide, trisaccharide, tetrasaccharide and pentasaccharide and so on till 10 you can write. Here, non-sugar are always called as a polysaccharides. Non-sugar are always called as a polysaccharides. The polysaccharides can be further classified into homopolysaccharide and heteropolysacharide. Homopolysaccharide and heteropolysaccharides. So this is a flow chart which you can easily recall and revise that classification of carbohydrate. Carbohydrate can be classified as sugar and non-sugar. Sugar can be classified into monosaccharide and oligosaccharide. The monosaccharide can be classified into aldose and ketose, whereas oligosaccharide, disaccharide, trisaccharide, tetrasaccharide, pentasaccharide. Whereas non-sugar, main classification, if we go to the non-sugar can be classified into polysaccharides, that is called as a polysaccharide. Polysaccharide further classified into homopolysaccharide. What is called as a homopolysaccharide? The polysaccharide means n number of monosaccharides are linked together, that is called a polysaccharide. In that, all n number of monosaccharides are same monosaccharides. All are the same. The n number we are saying no, n number of monosaccharide to give a polysaccharide. That n number are same type of monosaccharides are linked together. For example, glucose. This linkage is that is called a homopolysaccharides. All the monosaccharides are in the same type. All are made up of glucose, then it's called homopolysaccharide. If a different type is there, that is called heteropolysaccharide. If we now glucose and galactose or glucose and fructose, these mix together to give a heteropolysaccharides. If all the monosaccharide units are same, then it is called homopolysaccharides. If the monosaccharide units are different, then it is called heteropolysaccharides. Now let us detailedly study about the monosaccharides. Now let us see about the monosaccharides individually. What are called monosaccharides? Monosaccharide which cannot be further hydrolyzed. If saccharide further hydrolyzed, they are a different type. Now only we have seen the classification. Monosaccharides cannot be further hydrolyzed. That's the simplest unit of carbohydrate that cannot be further hydrolyzed to give a simple monosaccharide. That is called monosaccharide. So we can define what is called monosaccharide. Monosaccharide is nothing but it cannot further hydrolyzed. That is called a monosaccharide. Then monosaccharide, there are many number of monosaccharides are there. Many number of monosaccharides are there. But only 20 of them among them are naturally occurring monosaccharides. 20 among them are naturally occurring monosaccharides. There are many monosaccharides are there like glucose, fructose, these are the monosaccharides. Among them, 20 are natural monosaccharides. The remaining are artificial or synthesized monosaccharides. Only 20 are among them are naturally occurring monosaccharides. Then They have a general formula CnH2O n times. This is the general formula for the monosaccharides. CnH2n H2O n times. Okay, this is called a general molecular formula for the monosaccharides. Now, how the monosaccharides are named, how they are classified. There is a table is there based on the number of carbon, based on the functional group, type of sugar, and then example. These are the different. How to name them? That's we are going to see now. How the monosaccharides are named and how they are classified and named. Monosaccharides are how they are classified and named. First, we can see number of okay. This will make it like number of carbon first. Okay. Then functional group. Functional group present. Then nature of sugar. Nature of sugar. What type of sugar is it? Okay. Then example. Okay. So if there is three carbon. Functional group, two functional groups are aldehyde or ketone if it's aldehyde. If it is aldehyde. 3 carbon mean triose. Okay. Aldehyde present, so aldo triose. So aldehyde for aldo, 3 carbon triose. This is a natural sugar. For example, glyceraldehyde. Glyceraldehyde. Okay. This is 3 carbon. Nature of functional group aldehyde. So nature of the sugar you can see that 3 for tri, aldehyde for aldo, the word should be added, aldo triose. Example glyceraldehyde. Then if 3 carbon, if it is ketone, functional group is ketone, what to do? So keto triose. Keto for ketone, tri for 3 carbon, triose, keto triose. Example, dihydroxyacetone. In acetone, the 2 carbons are removed, 2 hydrogens are removed, and the OH groups are dihydroxyacetone. Now, 4 carbon. If a monosaccharide contains 4 carbon, then the functional group is aldehyde. Functional group is aldehyde. Then name is natural sugar aldo tetrose. Aldo tetrose. Aldo for aldehyde, tetra for 4 carbon was tetrose. Okay. For example, erythrose. Already we have seen the first erythrose structure, 4 carbons with it. If same 4 carbon, ketone functional group. Ketone is a functional group. So for 4 carbon, tetra is into keto tetrose. Keto for ketone functional group, tetra for 4 carbon was tetrose. The example for this keto tetrose, erythrulose. Okay, erythrulose. Okay, there's a difference. Erythrulose. Okay. Then same way 5 carbon. If it's connect 5 carbon. 5 carbon aldehyde. 5 carbon aldehyde. Okay, 5 carbons and aldehyde. That is aldo pentose. Aldopentose. Aldo for aldehyde, pento for 5 carbon, pentose. For example, ribose or ribose. Ribose or a ribose. If it contains 5 carbon, but the functional group is different. The functional group is ketone, so ketone. Functional group is ketone. Then 5 carbon ketone, there is a ketopentose. Ketopentose. For example, ribose. Okay, ribose. This is a 5 carbon. Likewise 6 carbon. What to do? 6 carbon. The functional group present in is aldehyde. Six carbon contain aldehyde, then it is called aldehexose. Hexa, 6 carbon aldehyde, aldehexose. Well known example, this is a glucose. Glucose can be given as an example. 6 carbon aldehyde. Same way, 6 carbon ketone functional group. The kind ketone functional group. So 6 carbon ketone, that is all ketohexose. Example, fructose. Simplest example, is fructose. So this is how to name the monosaccharides. That's we are here seeing today now. Based on the number of carbon, tri, tetra, penta, hexa, that named. If it contains 3 carbon, triose. If it contains 4 carbon, tetrose. If it contains 5 carbons, pentose. If it contains 6 carbon, then it is called hexose. Then nature of what are the functional group present? It may be aldehyde or ketone. Because carbohydrate is nothing but a polyhydroxy aldehyde or polyhydroxy ketone. There is 2 chances. It may be must be a aldehyde or ketone. So if it is aldehyde, 3 carbon, so aldotriose. For example, glyceraldehyde. Glyceraldehyde aldehyde functional group, that you know formula very well. Then ketone. The same carbon contains 3 carbon, but a ketone functional group, that is called a ketotriose. That is dihydroxyacetone. Dihydroxyacetone, you want what is formula of acetone? CH3, C double bond O, CH3. Okay, dihydroxyacetone. Here, if we take one H, CH2OH. This is called dihydroxyacetone. In acetone, 2 OH groups are added. This is dihydroxyacetone. Okay, that is called a 3 carbon. It contains 3 carbon and a ketone functional group. Okay, then 4 carbon. 4 carbon aldehyde. Aldehyde for aldo. 4 carbon tetrose. Aldo, tetrose, erythrose. Then 4 carbon ketone functional group, ketotetrose, erythrulose. Okay. Then 5 carbon aldehyde, aldopentose, penta for 5, aldopentose, ribose. Then 5 carbon ketone as a functional group, ketopentose and ribulose. Okay. Then aldehyde, aldohexose, glucose, ketohexose, fructose. These are the example. That is a monosaccharide. The structures of the glucose and the detailed study that we can see in the next classes. So far now we are concluding the lesson what we have seen today. Today the lesson name is biomolecules, that we have since started. Biomolecules is nothing but the chemical or chemistry behind the biology. That's a biochemistry. The name is biochemistry. What are the elements or molecules which activate the biological functions? They are called biomolecules. Okay, those groups are called biomolecules. For example, carbohydrates, proteins, lipids, and nucleic acid. These are the important biomolecules. Okay, there is a lesson content of these four. The detailed study about these four topics is only that biomolecule lesson. Among them, today we have seen that carbohydrate, that is introduction of the carbohydrate alone. Today we have seen carbohydrate means the compound which are having the carbon, hydrogen, oxygen. They are called carbohydrates. Carbohydrates are generally they are called as saccharides because most of the carbohydrates are sweet in taste. They are saccharides. Okay. Then chemically, the chemistry term, in the chemical term, carbohydrates are called as a polyhydroxy, more than OH group, one OH, that is polyhydroxy aldehyde or ketone, that is called a carbohydrate. The general formula for the carbohydrate CnH2O n times. Okay. Then how we can prepare the carbohydrates? The photosynthesis method we are preparing the carbohydrates. After that, a configuration of D and L configuration of the carbohydrates we have seen. That is based on the glyceraldehyde. Glyceraldehyde H is left, they are D form. H on the right side they are L form. They are based on this. If you find any carbohydrate monosaccharides, if you find that the structure, then you can say that there is a D and that will be a L. Like that we have seen. Then classification of the carbohydrates we have seen today. How they are classified based on the taste, sugar and non-sugar. Based on the hydrolysis, they can classify into monosaccharide, oligosaccharide and polysaccharide. Further, reducing property, based on the reducing property, they are classified into reducing sugar, non-reducing sugar, like that we have seen. Then entirely the flowchart of the classification we have seen. Finally, monosaccharide, what is called monosaccharide? The saccharide which further cannot hydrolysis to give a single monosaccharide units, that is called, cannot be hydrolysis. If it is sugar that cannot be hydrolysis, that is called a monosaccharides. Okay. Then monosaccharides, what is the general formula? The same CnH2O n times. Okay. Then how to name the monosaccharide? That we have seen. Monosaccharide can be named based on the number of carbon, based on the functional group, the different name we have seen. Okay. Thank you. Let us